Hello, and welcome back to my channel.
I did not turn it
A lot of you say to me, you're not a HEPA air filter, but you keep things clear. And to that I say, thank you.
What are you doing?
I'm teaching for the camera. I have to video myself teaching as part of renewing my certification. So Jason wasn't here earlier, so he's
I was in PSAT.
being my special helper. I know, and I'm going to give you extra credit for this. Okay, so earlier, the activity that you missed that goes along with these ideas about the brain. So our goal today is that we're going to draw a model of the brain's organizational hierarchy. You like those words? Those are big words, right? You know what organization is, how things are arranged. Hierarchy is like what's most important and what's least important, right? So your question for yourself is, what happens to your body when you exercise? Have you ever exercised? I'm not being a smart aleck. Like, if you've exercised, you notice that like your heart rate increases, right? And your respirations increase. You start breathing faster. You start breathing harder. And like you might feel tired. You might feel hot. You might get sweaty. All those things happen to you when you exercise. And then when you stop exercising, those things stop and your body goes back to normal. So like your heart rate slows back down. Your blood pressure goes back to normal. And your blood glucose goes back to normal. There's a word for that. Do you all remember that word from the Wayback Machine?
Back to normal.
There we go. Say it louder.
Homeostasis.
Homeostasis, which kind of does mean going back to normal. So homeo means same, and stasis means state of things. So your body likes to keep your conditions, your internal conditions, kind of about the same most of the time. We don't want to get too hot or we'll die. We don't want to get too cold or we'll die. We don't want to breathe too fast all the time or we'll die. We have to return to normal when we're done exerting ourselves. So there is a special thing that happens in your body called homeostasis, which returns your body back to its normal state of being most of the time. So earlier today, this is what you missed, Jason, when you were taking your PSAT like a hero, like a boss, like an extra credit earner. What you missed was we went outside and we took some timers. And first we took our baseline heart rate, like our resting heart rate. And for some people it was like, say, 64 beats per minute. Say use that number just for round numbers. And then you go outside and exercise and then your heart rate goes up. Like maybe it's 90 beats per minute while you're exercising. And then when you stop and you take your heart rate again, it goes back to normal. And so that is homeostasis. So my question was, what part of your body is responsible for maintaining homeostasis?
Wait, what is homeostasis?
So homeostasis is the fact that your body maintains this internal status of like things being relatively normal. Like your heart's not beating too fast all the time, not beating too slow all the time. It's normally right around the same range, right? So what part of your body is responsible for making sure that happens?
Cardiac system.
So that's definitely part of it, because that's getting the information, right? What's another part of your body that most certainly must be involved?
Your heart. What are you talking about? Oh, your lungs?
You're doing such a good job guessing, and you weren't even in that class. I really appreciate you. Yes.
Maybe
Your
with
brain.
your muscular system. Your muscular system.
So that's definitely involved in it, right? Because your muscles need more oxygen, because if you're going to be jumping up and down off of this wall or running up and down these stairs, your muscles definitely need more oxygen to make your body do what you want it to do. So your muscles are definitely involved in it. But whoever said brain is right. Your brain is kind of like command central, right? Giving all these messages. So which part of your brain is my question? We've got a reading out here that we're going to do together. Yes, dear? Yes, it's the same part that controls body temperature. Do you know what part of it is? You've had advanced classes. So it's kind of like being a cheater, pumpkin eater, but that's okay. You don't have the paper right in front of you. That's okay.
No, I have my paper that has all my definitions of homeostasis, hypothermia.
Here we go.
hypothermia.
I'm gonna give anybody who's participating in this extra credit, because I know it's not our normal class time, it's our normal homeroom time. You guys are being good sports by helping me out and letting me play teacher for a while here.
Cerebro.
Are we being paid for this?
In extra credit points, yes.
Hell yeah.
Cerebro.
There we go.
Cerebro.
Yes.
Celebrity.
So there are different parts of the brain, and they do different things. And our job is to draw a model of that organization. Because we have different parts, we want to keep track of the different parts, and just we need a quick and easy way to look at it and remember these things. So let's quickly read this paper together, and then we'll draw a model, okay? Should I read it out loud? Is anybody feeling like you want to read it out loud? How about if I read it and you make notes while I'm reading? Okay, is that cool? Because I know you guys have had a long day with testing and everything. Probably nobody feels like reading out loud. All right, the brain. What weighs about 3 pounds and contains up to 100 billion, with a B, billion cells? The answer is the human brain. The brain is the control center of the nervous system. It's like the pilot of a plane. It tells other parts of the nervous system what to do. The brain is also the most complex organ in the body. Each of its 100 billion neurons has synapses connecting it with thousands of other neurons. All those neurons use a lot of energy. In fact, the adult brain uses almost a quarter of the total energy used by the body. The developing brain of a baby uses an even greater amount of the body's total energy. The brain is the organ that lets us understand what we see, hear, think, or sense in other ways. It also allows us to use language, learn, think, and remember. The brain controls the organs in our bodies and our movements as well, like jumping up and down off of that wall outside. The brain consists of 3 main parts, so we need 3 main parts in our diagram: the cerebrum, the cerebellum, and the brainstem. The cerebrum is the largest part of the brain. Now I'm going to use this big black marker, and I'm going to go around the outside edge of the cerebrum part of my diagram. Can everybody see that from where you're sitting?
Yeah.
I know you're close. Jason, can you see right here, dear? Right there. I'm going to give you guys a lot of extra credit. Thank you for being such good sports. All right, so there's the cerebrum. So that's the largest part of the brain. So it's going to take up the largest part of our diagram too, right? It sits on top of the brainstem. The cerebrum controls functions that we're aware of, like problem solving and speech. It also controls voluntary movements like waving to a friend. Whether you're doing your homework or jumping hurdles, you're using your cerebrum. The cerebellum is the next largest part of the brain, and I'm going to change colors. Oh, here's purple. I'm going to use purple for this, and I'm going to draw a circle around.
Can we possibly use the same color?
Yep, as long as you draw a little label. Because I know I didn't put a whole bunch of colors in front of you, that's okay. But here, I used purple. So you see this one right here? All right. The cerebellum is the next largest part of the brain, and it'll be the next largest part of our diagram. It lies under the cerebrum and behind the brain stem. Kind of like if you put your hair in a bun, if you can imagine that, down low bun. The cerebellum controls body position, coordination, and balance. So whether you're riding a bike or writing with a pen, you're using your cerebellum. And the smallest part is the brain stem. I'll use yellow. There we go. See the yellow? That's the brain stem. That teensy weensy little part there. It's very important. It lies directly under the cerebrum, and it controls basic body functions. So those things that keep you alive, like breathing, heartbeat, digestion. You don't ever think about those things, right? Your body just does it normally, and it's your brain stem that makes those things happen. So it also carries information back and forth between the rest of your brain and the spinal cord. So very important parts. And you can see that one part is larger, one part is a little smaller, and one part is much smaller. So what kind of diagram could we draw to represent this idea? We've got a shape of a brain here, but say we don't want to draw that. If we wanted to just draw a regular old shape, what could we draw?
Wait for a brain.
Oval.
Could be an oval, and how would we organize the oval?
Like have lines in it.
Okay, we could do that.
Do like one big oval and then another like little like semi bigger one.
It could be a triangle. The brainstem could be a triangle, and the cerebral, the
This
cerebellum.
one could be a square.
Yeah, and but the
The
oh, it's a hierarchy, guys.
Look at you. Right, so this part would be the smallest part, which is the
The
brainstem.
and then the cerebellum, and then the cerebrum.
This is the cerebellum. And then this is the cerebrum?
Yeah.
How about that? That's a really good diagram, which counts as a model. It's a really good diagram because you can do it quickly, and it shows the relative size of each of these things, and placement, really. Now, earlier in today, can I share this to Shira? Because this was such a brainiac move that you did. Can I share it, please, please, pretty please, sugar on top of it? All right. So, Deshira said, what if you used your hand to model this? Now, she didn't understand when she was making this idea her own self, but this is a really famous idea that other people have had, and without knowing anything about it, she came up with this same really good idea. So if you imagine that your hand is your brain, then your wrist is your brain stem. That's the part that sticks down according to that little diagram, right? Now, if you put your thumb inside, fold your thumb inside, this could be the part of your brain that controls like emotions and fear, your limbic system. It's way down deep inside of your brain. And then you fold the rest of your hand over that, and it's kind of like the outside of your brain there, like the cerebral cortex. So it even is a good model because see the bumps and ridges that your hand makes? It's kind of like the bumps and ridges that you see on the outside of your brain when you're looking at your brain, right? So this was such a good thing that she came up with it without even realizing that she came up with this model too. So I was so proud of that. So thank you, Deshira. And thank you for letting me share. It was so good. So you could use this model of a brain, or you could use this model of a brain. Either one's fine. Models are super important to science class. We're forever making models, right? Because things happen too fast or too slow for us to be able to see them, so we need models. Or maybe the concept is too hard to see. Like, we can't just look at a brain and see what's going on, right? We have to do things to the brain and make tests and get results to know what's going on. But this can help us understand and remember. Yeah.
So like this is like where we get like the disease and the cerebral palsy and like stuff like that.
Mm-hmm.
It's from like not having like one of these, or is it just from having a defection?
Or bad communication between them. Mm-hmm.
Okay.
So you've had advanced classes, so you know that those neurons are going all over in your brain and they're going between other parts of your body, right?
Yeah.
So those, however far away your toes are from your spinal column, that's your longest nerve cell, right? So like a tall person would have longer nerve cells.
Yeah.
So there can be a lot of problems in that, just like you have a phone with a charger port that's kind of going wonky and it doesn't take the charge really well and you have to get it just so. That can happen in your brain too. The electricity can get
So what
disrupted.
Is there like a way to like fix it by like getting your brain to a certain like position? Like is there like a way to connect them perfectly? Like how
Wouldn't
you're,
that
like,
be